welcome back to my channel. In this video, you will be able to state the geometric properties of two-dimensional figures. Firstly, we need to define what is geometry. Geometry is a branch of mathematics focused on the measurement and relationship of lines, angles, surfaces, solids, and points. Geometry is from the Greek word geo, means earth, and metry means measurement. Measurement. Earth measurement. And the father or the founder of geometry is Euclid. Okay. Euclid is a Greek mathematician who wrote a series of 13 books about geometry called the Elements. And this series builds the foundation of geometry today. Next, we will discuss about plane figures. Plane figure is two-dimensional figure, or we can call that as 2D or flat figure. It can be, or plane figure can be made up of straight lines, curved lines, or both straight and curved lines. Examples are circle, triangle, quadrilateral, and there are kinds of quadrilateral, square, rectangle, rhombus, trapezoids, parallelogram, kite. Next, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, tridecagon, tetradecagon, pendecagon, hexdecagon, heptadegon, octadecagon, enneadecagon, isosagon, and so on and so forth. Polygons is closed plane figure with three or more sides that are all straight sides. What does it mean by polygons? Polygons is from the Greek word poly, meaning many, and gons, meaning angles. Many angles. It is a closed plane figure with three or more sides that are all straight sides. In here, the first example is circle. Circle is a plane figure. Circle is an example of plane figure, but not polygons. Okay? Circle is a plane figure because circle is a closed figure. But circle is not a polygon. Again, plane figure is two-dimensional figure that can be made up of straight lines or both straight and curved lines. It means that circle is a plane figure, but polygons is a closed figure, yes. Circle, we know that circle is a closed figure, right? With three or more sides, but the circle don't have three or more sides that are all straight side. That means circle is not a polygons. Why polygons start from 3 and then more sides? Because if we have only 2, or if we have only one side, and we can have only a line. And if we have two sides, we can have that one side and then two sides. these two sides, it is not a closed plane figure, right? So that means that we need to, or polygons start in 3 sides, and that is 1, 2, 3. This is what you call triangle, and then 1, 2, 3, 4 quadrilateral, 1, 2, 3, 4, 5. Or we can have that again, triangle. The first polygons is triangle, next is quadrilateral, which we have many kinds of quadrilateral, which we have square, rectangle, rhombus, trapezoids, parallelogram, then kite. Next is pentagon. Okay, triangle is from the word tri, meaning 3, and then angle. Next is quadrilateral. It means that from the word quad, meaning 4. Next, pentagon, from the word pen, which means 5, and then gon, meaning angles. Okay, wait. 5, or that is pen, 5, and then angles. Or we can simply say that as 5 gon. We can read that as pentagon or 5 gon. Next, hexagon, from the word hex, meaning 6, and then gon, meaning angles. Hep, from the word 7, and then gon, meaning angles. Or we can have that in hexagon, that is 6 gon. Next is 7 gon. Octagon, 8 gon. Nonagon, 9 gon, decagon, 10 gon, and so on and so forth. In here, octagon, from the word oct, meaning 9, nona, it means 9, and then decagon, it means 10, hende, 11, and so on and so forth. Next, what are the properties of two-dimensional figures? First is circle. Okay, we know that circle is a two-dimensional figure, but circle is not a polygon. Okay, circle is a round two-dimensional shape. Circle is a round two-dimensional shape. All points we have, circle consists of many points. This is the edge of the circle. Edge consists of many points. All points on the edge of the circle are at the same distance from the center. If we have here point, this is the center of the circle. If we will draw a line segment from the point or from the center to the edge, all points, if I will put many line segment here, all points are at the same distance. For example, this is 2 centimeter from here to here. That means that this is also 2 centimeter. Remember, all points on the edge of a circle are at the same distance from the center. So that means this is 2 centimeters, 2 centimeter, and so on and so forth. Next, radius is the distance from the center to the circumference of a circle. It is half of the circle's diameter. Okay, what is radius? Radius is the distance from the center. If we have the center here, then the half of the circle is what you call the radius. Okay, what is diameter? Diameter of a circle is equal to twice its radius. Okay, again, if we have radius here, and then the diameter is twice of the radius, it means that if this is 2 centimeter, then we can draw the diameter. That means this is 2 centimeter. From here to here, that's what you call the diameter. Again, radius is only half. This is radius. Only half of the diameter. Next, what do you mean by circumference? Circumference meaning all the way around of a circle. It is the line that goes around the center, the center of the circle. It means that circumference, this is the circumference. Again, this is the circumference. If we have the half of the circle, that is radius. If we have the line, if we have the twice of the radius, and that's what you call the diameter. Okay, next, the formula in getting the area of the circle is area of the circle is equals to pi r squared. R meaning radius and then squared. If you want to get the circumference, and that is circumference equals 2 pi r. If you want to find the diameter, and that is diameter equals 2r. Next, if you want to find the radius, and that is radius equals to the square root of the area of the circle over pi. Okay, what does it mean by pi? Pi has a value of 3.14159265359, and then pi is a ratio of circumference to its diameter, or we can write that as C to D or C over D. For any circle, dividing its C or the circumference by D, it will give the same number, and that is the pi value. Okay, remember, in any circle, even that is small or big circle, in any circle, if we will divide the circumference divided by the diameter, it will give the same value, and that is the pi value. Okay, let's move on. Triangle, the first polygon. Triangle is a polygon with 3 edges and 3 vertices. There are 3 kinds of triangle, and that is equilateral triangle. What do you mean by equilateral triangle? All sides and angles are equal. It means that we have 3 angles here, or we have 3 sides here. These 3 sides are equal. For example, in the first side, it measures 4 centimeter. Then the second side is also 4 centimeter, and the third side is 4 centimeter. Then all the angles are equal, and that is 60 degree. Why 60 degree? Because we know that in a triangle, all angles or the total angles is equivalent to 180 degrees. 180 degrees divided by 3. Why we divided by 3? Because there are 3 equal angles, and that is, we got 60 degrees. That's why we have 3 60 degree here. Okay, so that's all. We move on to the next one. Next, isosceles triangle. Isosceles triangle, 2 sides are equal. In the figure below, it shows that the 2 sides are equal. And note that in every triangle, the highest point is what you call the vertex point, and the highest angle is what you call the vertex angle, and in the bottom is what you call the base angle, and the bottom leg here is what you call the base. Okay, next, scalene triangle. Scalene triangle, all three sides have different lengths. In the figure below, it shows that all three sides are different. We have here 13, 9, and 14. They are not all equal. Next, the formula in getting the area of the triangle, that is, area of the triangle equals to base times the height. Next, the perimeter equals to the first side plus the second side plus the third side, or that is A plus B plus C. Next, quadrilateral. A polygon with 4 edges and 4 vertices or corners. And we have here, there are 1, 2, 3, 4, 5, 6. There are 6 types of quadrilaterals. First is the parallelogram. Opposite sides are equal and parallel. In here, the opposite sides, for example, this is the sides. The opposite of this side is in here, right? This side. They are equal and then parallel. What do you mean by parallel? Parallel are lines which do not intersect. For example, we have here, okay, this is straight lines and then this is a straight line. If this is 3 centimeter, this should be 3 centimeter. And if we have this line, if we have these two lines, then that's what you call a parallel, because they don't intersect. But for example, we have here, this is a line and then this is the line. For example, this is 3 centimeter and then this is 2.5 centimeter. This is not a parallel. Why? Because if we will continue this line, maybe in the end they will intersect. Remember that in the parallel, they should have the same length like this, so that they will not intersect in the end. Okay? Next. Okay, so that is parallelogram. Next, opposite angles are equal. For example, in here, this is 100 degrees and the opposite angle is in here, and it should be 100 degrees because it states that the opposite angles are equal. Then this would be 80 and this would be 80, and that is parallelogram. Next, rectangle. Opposite sides are equal and parallel. Opposite sides, the first sides here, parallel to here, and then in here parallel to this side. Next, all angles are right triangles. For sure, this is right triangles. Okay, next, square. Opposite sides are parallel. Yes, they are parallel. Next, all sides are equal. For example, this is 4 centimeter, then this should be 4 centimeter, this is 4 centimeter, and then this is 4 centimeter. Next, all angles are equal. Okay, that means this is square. Next, rhombus. Rhombus, opposite sides are parallel. In here, they are parallel, and in here also parallel. Next, all sides are equal. For example, this is 3, then this would be 3. All sides are equal. Next, opposite angles are equals. For example, in here this is 100, and this would be 100 also. Next, diagonals bisect each other at 90 degree in here. So if we have the diagonals and it bisect, then it would give 90 degree, and that is a rhombus. But what is the difference between square and rhombus? In square, all angles are right angles. That means the measure of all angles is 90 degree. And in rhombus, it states that in rhombus, the opposite angles are equal. For example, this is a rhombus. For example, this is 100, then it should be this is 100. And if this is 80, then this should be 80. But in square, it should be 90. All angles are right, and that is 90, 90, 90, 90. Okay? Next. Trapezoid. One pair of opposite side is parallel. Okay, so we have here parallel. And that's all. That is trapezoid. Next, two pairs of adjacent sides are equal. So we have here first pairs of sides. They should be equal. In here, they are equal to here. Next, in here, it should be equal to this side. Next, one pair of opposite sides are equal. It means that either in here or in here is equal. Next, one diagonal bisect the other. If we will draw a diagonal, then it should be bisect to another. And the diagonals intersect at the right angles, and that is kite. Finish. Next. Okay, this is the formula of quadrilaterals. In parallelogram, we have, in getting the area, that is base times height. In getting the perimeter, the sum of all sides. Next, rhombus, diagonal, the first diagonal times the second diagonal divided by 2. And then in getting the perimeter, 4 times s, or that is 4 times all the sides. Next, rectangle, in getting the area, length times width. This is the basic. Remember, you should remember rectangle and square. In getting the perimeter of the rectangle, that is 2L plus 2L plus 2W. Next, square, in getting the area, S times S, or S squared. And then in getting the perimeter, that is 4 times the side. Next, kite, the diagonal, or the first diagonal times the second diagonal divided by 2. Next, in the perimeter, the sum of all sides. Next, trapezoid or trapezium, that is, in getting the area, the sum of parallel side times the height divided by 2. Next, pentagon. Pentagon is a 5-sided polygon, or we can call that as 5gon. The regular pentagon is equiangular and equilateral. What does it mean by? Okay, wait. Okay. Wait a minute. Okay, got it. What do you mean by equiangular and equilateral? What is the difference? Equiangular is from the word equi, means equal, and then angular meaning angle. Okay, angle. It means that in a regular pentagon, all angles are equal. And equilateral, it means equal, and then lateral meaning sides, equal sides. So in here, all sides are equal and all angles are equal, and that's what you called a regular pentagon. Now the question is, why we have 108 here? We have 1 2 3 4 5 108. Okay, remember that in a triangle, the total angle is 180 degrees, right? Then if we will draw a diagonal here, and then we will draw a diagonal here, then we have how many triangle? That is one angle, two angles, and the three angle. That means that we have 3 angle times 180 degrees, and that is equals to 540. Next, we know that in pentagon we have 5 angles. That means we're going to divide it by 5. 540 divided by 5 is equals to 108. That's why we have 108 degrees in every angle. Okay? Next. Regular and irregular polygons. We know that regular is equiangular and equilateral. And then how about the irregular? Irregular is not a regular polygon. For example, in here, in a triangle, we have regular triangle, like the sides are all equal and the angles are all equal. In the quadrilateral, we have the square, and that is the sides are all equal and the angles are all equal. And in pentagon, we have 5 sides are all equals and 5 angles are all equal. And then in hexagon, the same, and octagon, the same. The sides and the angles are equal in here. How about in irregular polygons? It means that the angles are not equal and the sides are not all equal. In irregular, not all angles and sides are equal. But in the regular, it means that all angles and sides are equal. That is the difference between regular and irregular. Regular, all angles and sides are equal, and irregular, not. Take note, not all angles and sides are equal. So here, so that is regular and irregular polygons. Now we have 2 kinds of polygons, concave and convex. Convex polygon has no diagonal with points outside the polygon. If we will draw, for example in here, this is a perfect convex, because if we will draw, this is the point, right? And then if we will connect the corner to the another corner, then that is diagonal. And in the convex, no diagonal is in the outside. But in concave, at least one diagonal with points outside the polygon. So we have here the corners, and then we can draw a, or we can connect the corner in that is diagonal. That means that this figure is a concave figure. For example, more example, in here, this is convex pentagon. Why pentagon? Because there are 1, 2, 3, 4, 5. There are 5 sides. And this is irregular because the sides and the angles are not equal. And then this is convex. Why convex? Because if we will draw the diagonal, then there's no outside of the polygon. But in here, this is irregular, yes, because not all sides and not all angles are equal. And then this is concave. Why? Because in here and here we can draw a line. That's why this is a concave pentagon. Why pentagon? Because there are 1, 2, 3, 4, 5 sides. Next. Okay, next, another example again. This is what you called a irregular or regular polygon. Yes, this is irregular. What do you call this? Quadrilateral. And then convex or concave. Yes, this is convex. That means that this is irregular, convex, quadrilateral. Next, in here, irregular, convex, triangle. In here, 1, 2, 3, 4, 5, 6, 7, 8, octa. This is irregular, convex, octagon. And in here, we can draw diagonal here. That means these are all, we can draw diagonal. That means they are all concave. And this is irregular, concave, 1, 2, 3, 4, 5, pentagon. And in here, irregular, concave, 1, 2, 3, 4, 5, 6, 7, 8, octagon. Next, in here, irregular, concave, 1, 2, 3, 4, 5, 6, 7, 8, octagon. Okay, understood? Next, the formula in getting the perimeter of a regular pentagon, that is, we're going to add all sides, side plus side plus side plus sides plus side, or that is 5 times sides. Next, in getting the area of the regular polygon, that is 1/2 times the perimeter. You should get first the perimeter, and that, for example, this is 4, then that is 5 times 4, then your perimeter here is 20. Next, the apothem. What do you mean by apothem? Remember, in a circle, the half of the circle is what you call the radius, right? But in a polygon, from the center of the polygon to the midpoint of the other side of the polygon, in here, not here, this is not correct, but in here, in the middle of the side of the polygon, and that is what you call the apothem. 1/2 times the perimeter times the apothem. For example, this is 3, so that means 20 times 3, that is 60, and then you're going to divide it by 2, and that is 30. That means that the area is 30. For example, this is centimeter, then that is 30 centimeter squared. Next, hexagon. Hexagon is six-sided polygon, or we can call that as six-gon, and that is 120. Why is it that it is 120? How many triangles? Let's divide. 1, 2, 3. Okay, there are 1, 2, 3, 4 triangles, and that is 720. And then 720, you divide it by how many angles? There are 6, and that is equivalent to 120 degrees. That's why we have 120 degrees here. Next, why we have 60 degree here? Why? Okay, let's clear first the figure. Okay, why we have 60 degree here? Because take note that in a line it measures 180 degrees, right? And then if we will continue this, then that would be equivalent to 360 degrees. That means if we are going to divide this hexagon into 6 equal triangle, then we must divide this 360 to 6, and that we got 60 degrees. That's why we have 60 degrees here. And that is regular hexagon. Why regular hexagon? Because all sides and all angles are all equal. Next, okay, in the first figure, this is irregular. Why irregular? Because all sides, or the sides and the angles, are not equal. And then this is concave because we can draw outside diagonal. And then this is hexagon because there are 1, 2, 3, 4, 5, 6 sides. And then here, this is irregular convex. Irregular because not all sides and angles are equal. And then this is convex because the diagonals are only in the inside. Next, this is hexagon because there are 1, 2, 3, 4, 5, 6 sides. Okay, so that is irregular hexagon. Next, in finding the perimeter of the regular hexagon, this is the formula. Perimeter equals side, or that is 6 times sides. And then the same in getting the area of the pentagon, that is area equals to 1/2 times the perimeter times the apothem. The same in here. Next, heptagon. Heptagon is a 7-sided polygon, or we can call that as 7-gon. And in here, all angles are measuring 128 and 4/7 degrees. And then here in the center, it measures 51 and 3/7 degrees. And I hope you know why we have this measurement. I hope so. Next, And then here, the first figure, this is irregular concave heptagon. And the second figure, this is irregular convex heptagon. Next, formula of regular heptagon. And here, and getting the area, that is 7 times A, and that is the side. Next is R, this one, or what you call the apothem, and you're going to divide it by 2, and then to get the perimeter, 7 times the side, or the same also, perimeter times the apothem divided by 2, because we know that in getting the perimeter we will add all the sides. That's why we have 7A here. 7A here. This 7A is the perimeter, and this R is the apothem. So the same. This formula of getting the regular heptagon is the same also in the formula in getting the area of the hexagon and heptagon. Next, also in the octagon, in here, 8-sided polygon of 8 gon, that is 135 degree, and then there is 45 degrees here, and then this is 67.5. Why 67.5? Because if you're going to divide 135, that is 67.5. And then this is regular octagon because all sides and all angles are equal. And then this is irregular convex polygon, and in here octagon, and in here irregular concave octagon. Next, in getting the formula of regular octagon, that is area equals to 8A times R over 2, and then the perimeter 8A, or we can have that as perimeter times the apothem over 2, the same. Next, nonagon. Nonagon is a 9-sided polygon, or we can call that as n-gon. Okay, next the formula is this, the same. Next, but that is 9 because that is nonagon. Next, decagon. It is a 10-sided polygon, or we can call that as 10-gon, and this is the formula. And this will do also if you want to continue this, like in finding the area or the perimeter of the 11 gon, 12 gon, or 50 gon. It's up to you if you want to continue, but for now, this is the end of the video. I hope that you understand, and I hope that you know already what is the geometric properties of two-dimensional figures. Let's do some exercise. Number 1. Who is the founder of geometry? Number 2. What is the measure of the interior angle of a regular nonagon? Number 3. What is the area of the square if one side measures 5 inches? Next, what is the area of the rectangle if the base and height is 7 and 5 respectively? 5. What is the perimeter of the regular pentagon if one side measures 6 cm? Number 6. What is the area of the regular octagon if one side measures 10 cm and the apothem measures 13 cm? Next, what kind of polygon is the figure below? Next, what kind of polygon is the figure below? Next, how many triangle can you see in the figure? Next, is a rectangle sometimes a square? Yes or no? And if your answer is yes, explain your answer. This ends the video. See you in the next video. Teacher Rose misses you. Take care na ka. Bye!